Hi, I'm Liz, and this is my first video essay, and I decided to make it about quantum moon. The idea for this essay came actually from two very good questions by my mutual on Blue Sky, so shout out to them. And I will mention them towards the end. For now, I decided to make a little summary of all what you can find about the quantum moon in the game. And by the way, I mean Outer Wilds. And if you have not played this game, but plan to play this game, or you're in the process of playing this game, I suggest you skip this video because it's going to be nothing but spoilers. Or if you don't plan to play the game, I have to warn you that I'm going to proceed with this video as if you have played the game and you know some stuff. So this should not be your first video on Outer Wilds if you intend to acquaint yourself with it through the YouTube, for example. So quantum moon. So the player at first encounters quantum moon as this murky, grayish satellite that appears randomly on the orbits around all 5 planets that are in the Outer Wilds, from ash twins to dark bramble. So what you see on the first glance is that it changes places. You can easily lose it, and if you try to fly to it, inquiring what the hell it is, you probably will first launch a scout. The scout will disappear into it and will not give back any video feedback or any photo feedback. And if you try to fly into it, it'll just vanish out of your sight. You will not land on it. So this is the on-surface interaction and introduction into quantum moon. What it is, how to reach it, how to land on it, and how to reach its the most interesting, arguably, state, which is, spoilers, is orbiting the eye of the universe. You all get that from information left by Nomai on other planets. And this is a view of the log in this rumor mode, and here are all the pieces that are related to quantum moon. They're all colored in this pretty purple. And I will cover almost everything of it, except maybe for gravity cannon, because it doesn't really talk much about, it doesn't really contain much about the quantum moon. I think it's just a gravity cannon that Solanum used for her ship to travel to quantum moon. And as you may know, if you played Outer Wilds, there is no right order in which you learn stuff. So in this video I will assume this order of distance from the star, and we will start with the Ember Twin. There's nothing on Ash Twin related to quantum moon. Then to Timber Hearth, then to Brittle Hollow, and finally Giant's Deep. There's nothing on Dark Bramble as well. So let's start. And first is, and this is coincidentally the most juiciest bits are on Ember Twin. So I will start with Quantum Moon Locator, And I have embedded video into this presentation, but unfortunately, how videos in Google Slides work is a bit dumb, and I want to stop and resume playing many times, and in Google Slide that's impossible. It will keep going to the next slide. So instead, let me show you the video in VLC. So here it is, and here I am on the position of the quantum locator. So what is the quantum moon locator? It is a structure built by NOMI on the surface of the Ember Twin, and it tracks all the planets and quantum moon in real time. So it shows their exact positions. And with quantum moon, I assume that it does so by tracking its signal. So you may or may not know, you probably should know, that all quantum objects in this game emit so-called quantum fluctuations, and you can track them using it. You can track them using your signal scope, which catches those signals. And so I suppose that the quantum locator does the exact same thing. So here I arrived, and let's start the video. So at first, there is no quantum moon. We don't see it. And what I'm trying to do in this first seconds of the video is I'm trying to find the quantum moon. I'm looking around, I can't find it. I'm suggesting it may be under the horizon. No, it's not. And whilst I can't find the moon, it doesn't change its position. It stays in the same state. And by state I mean which planet is it orbiting. So I will use this word a lot in the future, but what I mean is that so the quantum moon has basically 6 states, which are represented by where it is in the solar system, which object does it orbit. So whilst I can't find it, it does not change its state. I'm looking around, I still can't find it. I can't find it for oh, there it is. Bam, I lose my FOV. I lose it from my FOV, and immediately quantum moon locator shifts and tries to find it in a new state. What's important here, and I want you to know that, is that I did not break FOV with quantum moon locator. I still see the quantum moon. I still see it, not the quantum moon. I still see the quantum moon locator. Okay, then it now finds it orbiting dark bramble. It leaves my FOV again. And what happens here is that it started erratically shifting, rotating. That means that the quantum moon is in its 6th location. And here I'm trying to stay, basically to keep my FOV stable or the same, to basically show that as long as we also don't make it leave our FOV, it will stay in this 6th location. So I'm keeping still for some time. It still is in the same place. Yeah, and so on and so forth. Then I decided to break FOV. Bam, I broke it. Like, I don't know where exactly this position is. We don't, I mean, that's the whole point. We don't know where it is, but it is somewhere, and I broke FOV with it. FOV means field of view, you probably know, but just FYI. Again, I broke FOV, and then quantum moon turned out to be... Well, basically, this is a video of me breaking FOVs all the time with the quantum moon, whilst keeping the quantum locator in my FOV. I still see the quantum moon locator, and this is an important thing. So here again, quantum moon is orbiting ash twins, so we don't see it. I think now it's under the horizon, maybe it's somewhere there. I'm trying to break FOV. I broke FOV. You see, that's the whole point. I did not see where the quantum moon... I did not see the quantum moon at all, yet I broke FOV with it as if I saw it, and that made it change the state. Now it's orbiting the... I should have waited there a bit longer to demonstrate it a bit more in detail. Here I'm also showing that if I don't look at the moon, so the moon never enters my FOV, it keeps still in the same state. See, nothing happens. It's in the same state. Bam, I broke FOV. I let it enter my FOV, and then I took it out of it, and it changed the position. And I think that's enough. This is where I'm again showing that if I don't change FOV, it stays in the 6th location. So here, so I was actually amazed a bit by this quantum moon locator, because it allows us to tell so much about how quantum moon works game mechanically without going into the files. So to sum it up, what can we learn from here? So quantum moon always exists in some state. It is chosen randomly, and it must be outside player's FOV when it is chosen. And it stays in this state indefinitely until only one condition is met. It leaves player's FOV, except when the image is taken of it. But you learn it later separately. And that's it. And what's important here, and what I kind of captured here, but it was not so apparent, is that you don't have to directly see the quantum moon for it to be in your FOV. In fact, it can be obstructed by something like sun or other planet, for example, Giant's Deep, because it's so big. It can go behind it, and you will, but as long as you keep looking at where the moon should be, it will stay in this state, despite you not seeing it. And this is important. Why it is so? I assume it's because of the signal scope. Because we can track it with the signal scope, and because the signal permeates everything and you can catch it anywhere, never mind what's in the path. So I guess that's because of that you can catch it. It doesn't matter that it's obstructed by something visually. And Yeah, this is important. Another thing is that all this time, in the entirety of this video, I almost never broke FOV with the quantum moon locator. That means that us observing the quantum moon locator does not influence the state of the quantum moon. Why should it? Well, because it is essentially the same as capturing an image. Because you have something that tracks the position of because it is the same, because in theory it is the same as the image. It kind of fixes the position or tracks the position of the object. Arguably, it does not mean that just because this tracker exists, the moon should always be in a fixed state, but it stands to argue that it would be natural if the quantum moon would stay in the same state when the tracker is observed, because you kind of obtain the information about the position. So if you have this information, why should its state change? I don't know, but it's the way it works. Which is weird, given that taking an image does fix the state for you. So it's a bit of a, I suppose it's a bit of a contradiction. But if the tracker would work the way I described, it has an interesting consequence, in a form that just by tracking the signal of this quantum object, the tracker itself becomes quantum, in a way that it's kind of tied to the position of the quantum moon. And it also means that if you observe the quantum moon but not the locator, you should know the position of the locator. It fixes the state of the locator as well, and vice versa. So just receiving the signal and tracking it makes you quantumly entangled, would make you quantumly entangled. And an interesting thing about image, and I have not tested it, to my shame, maybe I should have, but technically, if you take a picture of a quantum object, okay, whilst you look at it, the quantum object becomes fixed. It should kind of correspond to the image you took. But what if you stopped observing the image and stopped observing the quantum object? Could then the object change its state? And what would the image then tell you? Would it disappear from the image as well? Would then the image become quantum as well? God, I should have checked that. Although I think it just discards the image, maybe, because to get rid of the image you need to kind of de-equip the scout, and I think it deletes the image and you can't see it again, but I might be wrong. Someone needs to check me up on this. Sorry, I'm drinking tea. So, and it might, if you have seen Doctor Who, it might remind you of it, because in season 5, I think, if you remember Crying Angels, they were quantum as well, and an image of an angel is an angel itself. The image became if you took an image of an angel, it becomes quantum as well. And it could have been the same thing here, but I think we got I should have done that. Sorry, this is where I'm lacking, but I think it discards the image, otherwise it would be noticed by now. But in theory, what if you would not discard the image? How would it behave? That's interesting. Or does taking an image then fix the location forever? No, that would be no sense. It would make no sense. So yeah. And also with the tracker, you could, again, if it would work this way, the way I described, with it making it quantum, what if instead of a tracker you had a second observer? So you have an observer 1, which looks at the observer 2, and you have the observer 2, which looks at the quantum moon and carefully follows it, maybe like points at it. And the observer 1 knows that the observer 2 tracks the quantum moon. Does that fix the state of the quantum moon for the observer 1? And so like if they would turn to the quantum moon, would they find it in the same position? And when turning back, would they find the observer 1 in the same position, or observer 2 in the same position? And they were like, I think that you can propose 3 possibilities there. That one is God, I forgot them. But basically, one is when actually observer 2 becomes quantumly entangled too, and it's either fixing the quantum moon for everyone ever. I mean, yeah. So the first possibility was that it fixes the quantum moon position for everyone everywhere. It doesn't matter if they observe the observer 2 as well. Or it could fix the moon's location only for the observers who observe the observer 2. So whether you need to observe the observer is what fixes, is the difference between these 2 cases. And the case 3 is that when actually moon's state is subjective. So the observer 1 looks at the moon, so observer 2 looks at the moon, observer 1 looks at the moon, at the observer 2, but that does not do anything to fix the location of the moon for the observer 1, and they can find it, and then they can find it somewhere else. So they would report different states of the quantum moon at the same time. What is the truth? We don't know, because there aren't really in this game reports of 2 observer experiments with quantum objects. And I'm making an asterisk here because I'll cover it further on. There are kind of notions of this, but I'll discuss the problems with it later. So now let's move to the lake bed cave. And this is actually give me some time. And this is actually where we do get a hint at 2 observer experiment. Because what happened in the lake bed cave is that there were there's a bit about where I read the text. But so the story of the lake bed is that there were two normal researchers who came there and saw this quantum shard. And one of them, named Coleus, as it was climbed onto it, and the lantern of one of the other researcher, I think their name is Mallory, yes. Lantern went out, and it caused the shard with the Coleus disappear. And basically this cave tells us the rule of quantum entanglement, which says that if you interact with a quantum object, you kind of become quantum yourself. But what it means is that you can travel together with the quantum object if you are on quantum object. Basically switch between its states. So whilst there were two observers, for them both the light went out and they both have lost information about the shard, the quantum shard, here on cave shard, because it's how it's referred in the signal scope. And that's it. And I think there's nothing more that says about it. What kind of an interesting experiment they could actually do is that Coleus could stand on the rock and look at Mallory. Mallory looks at Coleus. The light is on. They are in complete silence. And at some point, Mallory turns around. What would happen to the shard and the Coleus? It is evident that for Coleus, nothing will change because they have not closed their eyes. Oh yeah, Mallory could, instead of turning, just close their eyes. Or blink. Yeah. So for Coleus, is obviously nothing is going to change. They know what the state they're in. They know where they are, and they have seen Mallory, and they're seeing Mallory. But Mallory loses the information about both Coleus and the shard. So it's kind of returning to the same observer conundrum, two-observer conundrum with observing quantum moon. Will the shard disappear, and then the Coleus's experience and Mallory experience basically will desync? They will observe different states. And what would happen if Coleus comes down from the rock? Will they appear for Mallory? Or will they be in this eternal desync? I don't know. And we'll never know. This is like... yeah. This is what I've been racking my brains about the past days. And there is no information to suggest a solution to this, because this dialogues in this case is basically just gives enough information for you to understand a particular game mechanic, and nothing more. Sorry. So, and what I do in the rest of the video is just I change quantum states of other objects, and this is kind of thing that you learn. Oh yeah, I demonstrate the quantum entanglement rule by traveling to the other place. Yeah, there's also some writing of Coleus that he discovered the quantum entanglement rule. Yeah, and what I do in the rest of the video is I show that the skeletons and this switch essentially also became quantum and changed their positions, which is an interesting trait that objects get when they are nearby quantum shards. They somehow obtain new states that they can change between. Okay, that's enough. So next is also on the in-between is the quantum cave. So actually we've been to the quantum cave in this video, but I wanted to show it separately because I've discovered an important discrepancy between behavior of quantum moon and quantum shards. So I have discovered that, and you will see this in this short video, is that for quantum shards, for some reason, it is important to observe them visually, unlike the quantum moon. So I pulled out, here you can see that I pulled out the signal scope, and when I flicker the lights, the cave shard instantly disappears and we will no longer see its signal whatsoever. And I don't even change FOV, I just flicker the light. So this is a drastic difference between quantum moon and quantum shards, which are speculated to come from the same place. But game mechanically, they behave very differently. I mean, not very, but differently. So while, as I have mentioned before, for quantum moon, it stays in this place, in this state, until you break FOV, unless you have taken a picture. And FOV includes when, and FOV is not broken even when the quantum moon is obstructed. For these quantum shards, it is important not to track it with a signal scope. So yeah, in the case of quantum moon, it was as if important for it to track with the signal scope. In this case, it is for some reason more important for it to track with your eyes. And also, if in the case of quantum moon, you not seeing it or observing the states and are not, observing the locations which correspond to the states the quantum moon at the moment is not in, does not change the state of the quantum moon. For the shards, it is different, and you observing where the shard could be and then breaking FOV with this potential location changes the state of the shard, while for quantum moon it doesn't do so. So there are two important differences here between quantum shards and quantum moons, and I would sign it as a problem because again, the game heavily implies that they have the same nature, they are of the same part, but yet they behave so differently for some reason. Yeah, and there is also what I demonstrate in the end of the video is that if you stand where the shard should be, it does not change its state. Well, and that's obvious because, I mean, you kind of know that the shard isn't there by standing in its place. That makes sense. Okay, so let's switch back to the presentation. Let me skip through it. So then we get to the quantum grove. It basically holds no additional information to whatever we found in the caves. It's just another shard with in some grove that changes its states by breaking FOV with them. There's also the same thing going on with the trees. And basically nothing new compared to the caves, except that you kind of, yeah. I suppose that's because, at least it was also the same way in my playthrough. I first explored the Timber Hearth, and this was your first experience with quantum objects, so they were kind of going light on it. The same goes with the museum shard, which is, I don't remember if there were objects that were also quantum there besides the quantum shard. So in a way, Quantum Grove is an expansion on it that shows that objects around it could also obtain quantum properties. Then there is the Tower of Quantum Knowledge in Brittle Hollow. Here is how it looks, and a bit of the inside. It also has its own version of Quantum Moon Locator, although a bit more primitive one. It just shows what kind of object it orbits instead of the exact location. And what it tells is basically just that it tells you the second rule, or whatever number of the rule it is, the rule of the sixth location, and basically is that to get to the sixth location you need to be in the Nomai temple that they built on the Quantum Moon on the North Pole, whilst you, for some reason, always arrive at the South Pole. It is also kind of unexplained why there is such behavior, why, never mind where you enter the Quantum Moon, you always are spawned on the South Pole. We don't know. Then there is in Giant's Deep the Tower of Quantum Trials, and it's basically to teach you the last third rule, or whatever order you choose for the rules, is the rule of the quantum imaging. And there's a whole series of trials that you can take to master this skill of fixing quantum skates by taking images of it. And what's interesting is that it obviously was constructed by Nomai, and it kind of implies that the Nomai could manipulate and have control over what kind of states there could be, which is interesting, and I will come back to that later in a bit. So lastly, Quantum Moon again, and there is a bit of a footage that I need to show you. Again, let me pull that in. There it is. So yeah, so when I took this footage, my main two goals was to look at how the ship behaves on the Quantum Moon, and to take a video of all the corpses of Solanum. I'm sorry. And it starts with this funky situation that will occur in a few seconds. So I go to the Quantum Tower, I turn around, and this damn rock spawns under my ship and sends it flying. So I no longer can track my ship in this place. I'm looking a bit sad and lost, and interestingly, that you see by the image of the scout that actually it is somewhere in the atmosphere. It somehow got stuck in the atmosphere of so here's Solanum, the corpse of her. And what I'm showing here, and what I wanted to show here, is that there are different states of objects, including the Solanum's corpse, on the Quantum Moon. So the Quantum Moon has itself, like as a whole object, 6 separate states. But there are also sub-states on the quantum moon in each state of the quantum moon, which basically is represented by different locations of the towers or rocks or Selenium's corpse. So it's like an addition to the so the state itself, like the position where the moon what planet the moon is orbiting, is not completely fixed itself. It has sub-states. Okay. Poor lass. Stop bothering her. Go on. Okay, also there is Selenium's ship. It's also present in all 5 versions. Oh, 6 version. No. Is there a Selenium ship on the 6th location? I don't remember. Either way. Yeah, this is on Ash Twin Moon. Also several states of her particularly, and also her ship. On the Dark Brambles Moon. And on Brittle Hollow. Yes, many states. Well, not many, okay, maybe 3 or 4. And lastly on Timber Hearth's moon. And here I came back. It was like a different loop. And here I'm moving erratically because I wanted to test if my ship is quantum and can change states. No, it stays the same, in the same place as I have placed it, and is not influenced by it in the slightest. So here's also this Nomai's temple that they built, and basically it serves as this cover from the light, natural illumination of the quantum moon, in order to lose information about the environment and switch states. And here I switch states. It brings me right away to the 6th location. Then I switch it to Ash Twins, and to see if my ship is there. It's not. The ship has disappeared. Yeah. Yeah, I just didn't want to lose the... So yeah, so I didn't find it there, so I changed the state back to the Timber Hearth. We're in the Timber Hearth, and there is no ship. The ship just disappeared. So why have it disappeared? I fully understand game mechanically why it did, because it's obvious that when you change states, there is a very high probability that it's going to clip into something and just break something, or fall or fly away into the... And as you could see, I first spawned into the sixth location, and there's, if you don't know, there's a wall, so kind of like you shift into this yeah, you basically shift into the wall when you try to get into the sixth location, not from the North Pole. And I guess if my ship would remain the same coordinate upon the planet, it would just get stuck in the textures. So I don't understand why they removed the ship, but how to explain that law-wise, I don't know. It's also kind of like another question, but a minor one. Also, an interesting thing that you could notice is that when you change states with this tower, you don't change the coordinates on the planet. You are kept in the same place, like in terms of coordinates on the sphere that you track through this globe on the left. And you can't really say that there's a good reason why. You could say that, well, you observe this globe, so you know your position, and that should fix it for you. But if you noticed it, and you might rewind the video to the section with the lake bed, I think, yeah, with the lake bed cave, we observe this sphere and our position on it there as well, but it does change. So if that would be a factor, we would not be able to change our quantum states together with a cave shard, but we do, so it doesn't matter. Unless again quantum moon has different properties compared to the shards. Maybe, or JB not. So this is like also an interesting problem or a question, like what's up with that? I don't understand game mechanically why they didn't do so, because that would mean that going through the whole puzzle of switching states to get to the temple at the North Pole would be meaningless. You would be just able to switch between all the sub-states of this tower and eventually arrive at the tower in the North Pole. But law-wise, this is a discrepancy, because if, in a way that it's not clear if observing this globe does anything to understand the quantum position, because here you could argue that it works, but why doesn't it work then with the cave shard? Why can we just change? I mean, I guess I could show you, but again, you can just rewind and find it. And lastly, what this footage does not include is me going to the sixth location and talking to Selenum. And you find her there alive, despite all the corpses, all 5 corpses that we found in this footage. And so it provokes a lot of questions. So, and this is where I tell you these 2 questions by my mutual. So first one, how the hell is she alive? Because as you might discover from the rest of the game, that since this comet eruption happened that killed all the Nomai, including Selenum in all other states, it happened 300,000 years ago. Now, we don't know the Nomai lifespan, but we can argue that it's not that long. So Selenum could not have lived all this time there. Besides, living this many years would probably drive you insane. Also, it's kind of curious when they say years, what kind of years? I mean, they probably mean their hometown, home planet years, probably. But yeah, even in the context of the system of the solar system in game, different planets have different length of years, obviously. Okay. So apparently, I mean, the conclusion or the assumption that you must make from this information is that the time moves differently in the sixth location, which basically helped Selenium to stay alive and wait for us. But when you come there, the time, you can still encounter the end of the loop there. You cannot stay there indefinitely and meet the loop just outside of that location. No. You can meet the loop there, and it will come to you at the same time as outside. So you don't experience this time dilation. Why? I don't know. The only assumption that I can make, the hypothesis that I can make, is that this time dilation is time dependent, and that the fact that the universe is ending have turned off this time dilation or something, whilst it was true in the past. Okay. So, and another problem or another question is, if Selenium is alive, she is an observer who fixes the state of the moon. So why the moon isn't always at its sixth location, if Selenium is there to observe it? And essentially we do get finally some version of two-observer experiment here, and we can see that her observing the quantum moon at its sixth state does not influence our perception of the states of quantum moon, though there is a weird element to it, because after all we find Selenium on other states of the moon as well, dead. So is she really an observer, or did she lose this state or not? But apparently not, because I mean, what would it mean? How could she do that? Because she needs to stay in this state of the sixth moon, for herself at least. Though she, at the same time, in dialogue with her, she does argue that she feels that she may not be entirely alive. So it is somewhat of an open question. What's wrong with Selenium, and is she an observer? So let me summarize the problems. There are two main ones. First, we have discovered the quantum moon and quantum shards show different behavior, either in how you fix their states or in terms of, I guess, traveling with them, in terms of quantum entanglement with them. And the sixth location time dilation, I've just explained that. It's inconsistent, or at least maybe time dependent. Which leads us also to some questions. So the big one, and they're all kind of tied together, is what are the states and also the substates of all the quantum objects that we have observed? Where do they come from? Like, what is their physical origin? Like, if you take quantum objects in IRL, different states correspond to different energy levels that are kind of come from being in a specific field. I mean, it all depends on the specific Hamiltonian that you will set up for your system, and it will yield you all kinds of solutions depending on it. The only thing that is the same is that the amount of states will be the states will be discrete, except if you try to take extremely complicated systems, you will end up with so many states that they form a continuum and you cannot differentiate between them discretely. But what is the origin of the states here, and how do you interpret that? When I was rehearsing, when I was thinking about this problem, I had this hypothesis that maybe they could represent kind of possibilities in a way that the moon could have formed at this planet or at the other planet, and so on and so forth. Or when the trees grew, they could have, or when the tree seed was planted somewhere, it could have landed there, and that creates these different positions for them when the quantum object is nearby. So basically, there is like, you could imagine a whole range of alternative universes where the moon formed in one place, the seed has fallen in another. Solanum either arrived at the sixth location or not. And quantum objects, by their nature, kind of can invoke the states from other universes somehow and show you different versions of them depending on where you look, I guess, or whatever. And why am I suggesting this explanation is because it kind of correlates with the purpose of the eye of the universe. This is like, I'm getting spoilers, is the purpose of the eye of the universe is for you to observe it, to collapse all the possibilities of the future universe into a one specific universe. So it could also, by this nature, track the past possibilities, and in this explanation or this interpretation kind of feeds into the idea of kind of relativity or kind of subjectivity of observing a state, because if you compare us and Solanum, we are separated by many years, and for Solanum she experiences one state that she came through, but for us, so distant in the future, she could have arrived at any of these states, and the quantum moon just presents them to us as possibilities. Yes, but it also but this also implies that to see these different possibilities that could have happened in the past and led to consequences now, we need to assume some kind of distance from them. They need to be in the past, because if we arrived on our ship there is no alternative possibilities of where the ship could be, and we see that the ship does not become quantum when we arrive on the quantum moon. It just disappears for game mechanical reasons. But when you stay in the same state, it does not get substates as if you could have arrived there and there and there. But there is a problem with this explanation. And this problem is called Tower of Quantum Trials. Because it means, because the existence of such a tower with such trials that were made artificially by Nomai is that they could control and infer, and like they could force their gravitational crystals, because they use them in these trials, to be in the very specific states and change between them. In this tower alone, Nomai demonstrate the control over quantum objects and the ability to set them up and their states in the way they want. And so it kind of ruins the whole explanation that this must be, because this would not be a past event for them. They could not have placed one crystal and then waited for their parallel selves to place it at different positions. Also, what you would kind of expect, that there would be at the same time a continuum of such states, because what would be the reason for them, for example, a tree seed to fall in this particular limited amount of positions, unless there is a limited amount of universes, I guess. It should be a continuum. And I suppose that if the game could weigh an infinite amount of memory, it would be possible. Although I think you can program it without weighing it. Yeah, I guess you could just set up the area in which each tree could randomly spawn instead of fixed locations for them. But I suppose that they didn't go through with it and instead chose like very specific locations, so they could avoid like clipping issues or something. I suppose it might have been just more difficult game mechanically. So yeah, and there's also a very unclear situation with how would quantum objects behave when there would be serial observers, and would the observers become quantum themselves only by observing stuff like to each other, and is it subjective or not, and so on and so forth. And the status of Selenium as an observer is an open question as well. I don't yet know what to make of it, and I'm not I mean, I want to note here that the game does not provide enough information to draw conclusions here, and even when we looked with the quantum moon locator, the quantum moon, we looked at its game mechanical behavior. But does it really mean that the quantum moon, regardless of the observer, always exists in one state and just changes it when you lose FOV? I mean, when it leaves FOV of the observer, or when we don't look, it actually exists in a superposition of these states, whatever it means. We don't know. I mean, we know how it is game mechanically, but it does not give us an answer what it is law-wise, canonically. And the same thing with the Selenium and several observers. The game does not give us this information. We can only speculate, and that's what I'm doing here, essentially. So yeah, I guess that's it. What I wanted to say, that it's a treasure trove to fantasize and speculate how it all works and why. And the game is being murky on the purpose, or maybe not. But let it be. It's a great game nonetheless. There should be always some room for interpretation and your artistic expressions. Because why not? Also, I wanted to make a little note in the end about what is quantum physics IRL, at least like on a philosophical level, I guess. But you know what? I won't. I am not an expert on quantum physics. I have a leaning towards a certain interpretation, which is like the one that makes the least assumptions, I suppose, and can be easily summarized by, we don't know, it's just a model, and all we can do is just making models that meet the observations and experiments at some points. And this is basically the philosophy of science. So thank you for watching, and I suppose that's all. Goodbye. Let me turn it off.